All right, so we are looking at exponential growth, exponential and logarithmic applications. And you can see we have these same formulas that we had for exponential applications. We're going to be doing the same sort of thing, only we're going to be using logarithms to solve a lot of these. In fact, our first problem is the same problem we had way back when. Okay, upon graduating from college, Ashley took a job with a starting salary of $40,000. She can expect a 6% raise in pay each year. In the notes for 5-6, we found by graphing that after 6.959 years, Ashley would be earning $60,000 a year. Confirm this result algebraically. So now we can solve this directly instead of solving by graphing. All right, so she's starting, our A sub 0, she's starting at $40,000 a year. She's increasing by 6%, so that's going to be 1 plus 6%, 1 plus 0.06, 1.06. This is 1 plus 6% to the t power, and we want to know when this equals 60,000. So we're solving for t here. First step is to divide both sides by 40,000. On the left side, I get 6 over 4. On the right side, the 40,000s are going to cancel. I've got 1.06 to the t. We'll take the log of both sides, natural log I'm going to use. We'll bring the t out front, so ln of 6/4 equals t times ln 1.06. Divide both sides by ln 1.06. So t equals ln 6 divided by 4 over ln 1.06. So ln 6 divided by 4, close my parentheses, divided by ln 1.06. And I get 6.9585, which rounds to 6.959, just like we expected. T equals 6.959 years. Okay? Number 2. Living organisms can be dated by the amount of carbon-14 present at time t compared to the amount present when the organism was alive. The half-life of carbon-14 is 5,730 years. How long would it take for a 185 microgram sample of carbon-14 to decay to 24 grams? All right, so this is a half-life problem. So our formula is A of t equals A sub 0 times 1/2 to the t over k. Okay? My starting amount, I have 185 micrograms at the beginning, times 1/2 t over my half-life amount, 5,730, and this is going to be in years, so my t value will be in years. And I want to know how long before this decays to 24. We only have 24 grams left. Okay, first step is going to isolate, divide by 185 on both sides, it cancels on the right. If you want to reduce it on the left, you can. I would suggest not doing that. 1/2 to the t over 5,730. We'll take natural log of both sides. We'll move this to the front. So now I've got ln of 24 over 185 equals t over 5,730 times ln of 1/2. So I'm going to divide by ln 1/2. So now I've got ln 24 over 185 divided by ln of 1/2 equals t over 5,730, and then we'll multiply times 5,730. And t equals 5,730 times ln 24 over 185 divided by ln of 1/2. All right, so let's see what we get here. 5,730 times ln 24 divided by 185 divided by ln, I'm going to put in 0.5 for 1/2 here. and I get t is, it says round to the nearest 100 years, so 882, that's going to round up to 900 years, 16,900 years roughly. 16,900. Okay. Suppose a culture of bacteria is put in a petri dish and grows continuously. There's my key word, continuously. Culture doubles every 4 hours. All right, so if it grows continuously, continuous growth or decay, A of t equals A sub 0 of e to the kt power. All right, and I need to solve this. I need to figure out what k is. So we're starting with, we actually don't know how much we're starting with, but it doubles every 4 hours. So if I start with a sub 0, then I'm going to have twice as much, 2a sub 0, 2 times a sub 0 equals a sub 0 e to the k times 4. And so everything's going to be in hours here. So if I divide both sides by a sub 0, my a sub 0s will all cancel out. I've got 2 equals e to the 4k. Do natural log of both sides. And I've got 4k equals natural log 2. And k equals natural log 2 divided by 4. So in my calculator, natural log 2, close my parentheses, divided by 4 is 0.1733. So my formula is A of t equals a sub 0 e to the 0.1733 t power. And that should double every 4 hours. If the initial amount of bacteria is 100, how many bacteria will there be in 15 hours? All right, A of 15 equals 100 e to the 0.1733 times 15. So let's see what we get here. 100 second ln gives me e to the 0.1733 times 15. 1345.7 roughly, since it's bacteria, we'll round to the nearest whole number here, 1346 bacteria. Okay, 1346 bacteria. When will the bacteria count be 350,000? All right, so 350,000 equals 100 e to the 0.1733 t. We'll start by dividing by 100. That's going to cancel out my last two zeros. So 3,500 equals e to the 0.1733 t. Take natural log both sides. My right side is 0.1733 t. Left side is natural log 3,500. Divide by 0.1733. T equals ln 3,500 divided by 0.1733. Getting about 47.089 hours. 47.089 hours. All right, last ones. 24. Suppose you plan to invest $2,500 at an annual rate of 7.5%. How much will you have in the account after 5 years if the balance is compounded quarterly? All right, so quarterly compounding, we have compound interest. A of t equals p times 1 plus r over n to the nt power. So I'm looking for 5 years. So A of 5, I'm going to have 2,500 at the beginning. 1 plus 0.075 is my rate. Quarterly is 4 times a year. 4 times 5 is my power. So 2,500 parentheses 1 plus 0.075 divided by 4 to the 4 times 5, 20th power, 362487. Okay, $3,624.87. How long will it take to have $10,000 if the balance is compounded quarterly? So this time 10,000 equals 2,500 times 1 plus 0.075 over 4 to the 4t power. We'll start by dividing by 2,500. I've got 100 divided by 25, which I know is 4, equals 1 plus 0.075 over 4 to the 4t power. Natural log both sides. 4t natural log of 1 plus 0.075 over 4. Someone divide by 4 natural log 1 plus 0.075 over 4. 4 natural log 1 plus 0.075, 4. So my 4's cancel, all that cancels. T equals ln 4 divided by, let's do it this way. I'll tell you what, let's use math and left arrow fraction. All right, ln 4 on top. On the bottom I've got 4 ln 1 plus 0.075 divided by 4. 18.657 years. How long will it take to have 10,000 if the 2,500 is compounded continuously? For continuously compounded, it is the PERT formula. A of t equals p times e to the RT power. So 10,000 equals 2,500 times e to the 0.075 t. Divide by 2,500, divide by 2,500. We have 4 equals e to the 0.075 t. Natural log both sides. 0.075 t equals natural log 4, and t equals natural log 4 divided by 0.075. Natural log 4 divided by 0.075. 18.484 years. So less than 2/10 of a year difference there. A little bit faster, but not a whole ton faster. Okay? Put years there. All right. I was going pretty quick there, but hopefully you'll get through this. If you have any questions, let me know. Otherwise, I'll talk to you tomorrow. We have one more lesson on applications, then we'll have a couple days of review. Our test is, we're aiming for the test to be on Monday. Okay? Talk to you later. Bye.